So far, we've identified over 4,000 planets beyond our solar system, and a handful of them are small, rocky places that could be like Earth, if they have atmospheres similar to ours. With the next generation of space telescopes, we'll be able to study these atmospheres for real. But that doesn't mean that we have to sit around twiddling our thumbs in the meantime. So to prepare for future research, a team of astronomers decided to study Earth as if it were an exoplanet hundreds of light years away. And last week in the Astronomical Journal, they confirmed that a signal in their data could be used in the hunt for alien life. When an exoplanet travels between its star and Earth, a very small amount of starlight passes through its atmosphere before venturing on toward our telescopes. Astronomers can then interpret that light to determine what the planet's atmosphere is made of. That's because each chemical compound interacts with light in a unique way. It absorbs a specific combination of colors. A fingerprint we call an absorption spectrum. So by carefully studying the light from a star over time, we can figure out what compounds were in its planet's atmosphere. So far, astronomers have done this with a small handful of gas giant exoplanets, but they haven't been able to go much further than that. Right now, we just don't have the huge telescopes you need to study the thinner atmospheres of smaller, rocky exoplanets, but we can still prepare for when we do. In January 2019, a team of astronomers pointed the Hubble Space Telescope at the moon during a total lunar eclipse. During a lunar eclipse, the Earth is perfectly aligned between the sun and the moon, so from the moon's perspective, Earth mimics an exoplanet passing in front of its star. While most of the sunlight gets blocked by the Earth, a small amount gets filtered through our atmosphere and bounces off the lunar surface. That's actually what gives the moon that distinct red hue during an eclipse. But it's not just red light that makes it through Earth's air. The team used Hubble to study both visible and ultraviolet light that filtered through Earth's atmosphere and then bounced off the moon. And in that light, they were looking for the absorption spectrum of ozone, a molecule made of 3 oxygen atoms. Regular oxygen gas is made of 2 oxygens bound to each other, but when an energetic photon of light hits it just right, they'll break apart, and those individual oxygens will go bind with another diatomic oxygen, forming a molecule of ozone. But here's the key: almost all of the oxygen in the atmosphere is there because of photosynthetic life, from bacteria to plants. So searching for ozone in an exoplanet's atmosphere could be an indirect way to see if anything lives there. And in this case, the test worked. Hubble successfully detected ozone in Earth's atmosphere, so if our next generation telescopes can do the same for a distant world, it might mean some form of life is on its surface. I mean, we'll also want to confirm that by looking at other gases life makes, like methane. That's one thing the future James Webb Space Telescope will be able to do. But Webb will not be able to see ozone's ultraviolet influence, so we're going to need a fleet of telescopes working together to find Earth 2.0. While we wait for that, we'll also be studying the planet humans will visit next, Mars. Mars's interior is kind of like a time capsule. It doesn't have tectonic activity like Earth, so the way that it looks now is similar to its ancient history. And since astronomers are pretty sure all the rocky planets in our solar system formed in similar ways, that gives us a sense of what Earth's insides looked like a long time ago. Now, historically, we haven't known a lot about Mars's interior, but thanks to NASA's InSight lander, we're getting a better look at it. And last week in Geophysical Research Letters, scientists revealed that we might finally know how thick its layers are. InSight landed in Elysium Planitia in November of 2018, carrying a seismograph to listen in on Mars quakes. When a quake happens, seismic waves travel through the planet and they move differently through different kinds of rock. So by analyzing those signals, scientists can work out how Mars's insides are structured, and that's exactly what one team has done. Beneath InSight, they've concluded that the crust appears to go almost 35 kilometers deep, and it's made mostly of the volcanic rocks basalt and andesite. Then there's a transition known as the Maho between the crust and the denser mantle. Within the mantle, the team also identified a special depth where a type of olivine experiences enough pressure and heat that it reorganizes itself into a different mineral called wadzleyite. This olivine-wadzleyite transition, yeah, geologists, they're just great at naming things, happened about 1,100 to 1,750 kilometers beneath InSight. Then by 1,600 kilometers, we reach the iron-rich core, which makes the core about 3,600 kilometers wide. Models and some past measurements have predicted similar sizes for these layers, but these were the first direct measurements, and they confirm that we're on track. So now we can keep trying to figure out how Mars and the other terrestrial planets formed and evolved. Still, InSight is just one research station, whereas on Earth we have tons of them, and Mars actually has a lot fewer quakes than Earth, so we have fewer data points as well. So we still have a long exploratory journey ahead of us. If you want to learn more about what InSight is up to on Mars, you can watch our video about its first results, and as always, thank you for watching this episode of SciShow Space News.